Hi, we're Jarrel and John, and this is our short presentation for MATLAB Problem 1. Spool on truck bed from the Machines and Mechanisms mini project. We'll walk you through how we approach the physics, the maths, and the MATLAB model to analyze the behavior of an unfastened spool when a truck accelerates.
The setup is quite simple but a bit sneaky. We have a 500 kilogram metal spool sitting freely on a truck bed. The truck starts accelerating forward at 3 meters per second squared. Our goal is to determine four things: the normal force on the spool, the angular acceleration, the translational acceleration of the spool center, and the friction force between the spool and the truck bed. We assume that no slipping occurs, meaning that static friction is holding the spool in place for now.
To get these values, we used free body and kinetic diagrams to lay out the forces and motions involved. The known values included the mass of the spool, gravity, radius of gyration, and the truck's acceleration. After we related the angular acceleration to the linear acceleration and used the known mass and radius of gyration to express the moment of inertia.
To test our hand-derived formulas, we plugged them into the MATLAB model provided. We assumed a static friction coefficient of 0.1. Running the Simulink model showed that the required frictional force was far greater than what the static friction could provide, so our assumption of no slipping did not hold. This was key as it showed us how sensitive the system was to frictional values. If the friction was too low, the spool would slip.
In task 2, we explored what happens when you vary the parameters. We adjusted the mass, acceleration, and friction coefficients using the sliders in Simulink. The main takeaway: higher static friction coefficients reduce slipping. When static friction was increased from 0.1 to 0.7, we saw a huge drop in slippage, and the model aligned closely with our theoretical predictions.
This task helped us connect rotational dynamics to real-world conditions like friction limits. It also taught us that assuming no slip wasn't enough, and that we needed to verify that with actual numbers. Using MATLAB alongside theory really deepened our understanding.
Thanks for watching our presentation on MATLAB Problem 1. We hope this helped explain the process of modeling and verifying the physics behind a deceptively simple setup, a spool on a moving truck. Let us know if you have any questions.